So today we're going to talk about naming the polyatomic ions. We're still talking about ionic bonding. But you have to, so first of all, you have a list of polyatomic ions on your reference table. You'll not have to memorize those because they're on the reference packet, but you are going to want to become very familiar with them because they'll make your practice work go a lot faster. The more we use them, of course, the more you'll learn them. So the only difference really in naming the polyatomic ions and naming binary compounds is that there are more than two elements in the compound, and sometimes you have to use parentheses in the formula. I can't spell today. Parentheses in the formula. So here's some examples. So we see we have 1, 2, 3 elements. So that's our first clue that we have a polyatomic ion present. So if we look on our reference packet, on that last page, it tells us our list of polyatomic ions. And it tells us that NH4 is called ammonium. And so now that we've named NH4, that's the ion ammonium, then Cl still works like it did before, it would be chloride. For our next example, we have Fe, which is iron. And again, we have the metal, so we need to think about where is that metal. Is that in group 1, 2, or 3? No, so it's going to have a Roman numeral. So we figure that out from knowing the polyatomic ion. So NO3 here, if we look that up, we'll find that's called nitrate. Now we see on our reference packet that nitrate is a -1. And there's 3 of those. So again, we're multiplying, and that ends up being a -3. And so iron has to make that make that a 0, so it has to be a +3. And so that's going to be iron 3 nitrate. And then here we have lead. And again, lead's in group 4, so that's not 1, 2, or 3, so we have to put our parentheses in here. And then SO4 is called sulfate. And if we see in our reference table that sulfate has a -2 charge, and there's 2 of those, so that makes that -4, so lead has to be a +4. So this would be lead 4 sulfate. Next we have Be, that's beryllium. Right, beryllium's in group 2, so it needs no Roman numeral, and we find HCO3 on our reference packet, and we see that's called hydrogen carbonate. You will sometimes see that written as bicarbonate instead. It means the same thing. Bicarbonate is also HCO3 -1. Then we have Mn. Mn is manganese. Manganese is not in group 1, 2, or 3, so we'll have to put parentheses and find the Roman numeral. But first we find our polyatomic ion, SO3, and we'll see that that's called sulfite. Alright, again, sulfite is a -2. There are 3 of those, so again we're multiplying. So that makes a total of -6. So the manganese have to be +6. But there's 2 of those, so that means each one of those is going to be a +3. So this is manganese 3 sulfite. Then we have aluminum, and aluminum is in group 3, so it needs no Roman numeral. And we find on our sheet that our polyatomic ion Cn is called cyanide, and so that's just aluminum cyanide. So now let's look at writing the formulas. So here we have chromium, and this is 6-phosphate. Again, this means that chromium is a +6 charge. If we look up our polyatomic ions, we'll find that phosphate is PO4, and it's a -3. So a good idea is to just write your ions with their charges so you can figure out what we need. So again, these have to add up to 0. So how many -3s do we need to make that equal 0? Right, we'll need 2 of those. So we'll have Cr and then PO4. Now here's where the parentheses come in. We can't just put a 2 here because that makes 42 oxygens, which is not what we want. We want to say that there are 2 phosphates. And so we put parentheses around the PO4 and then the 2 on the outside. Next we have vanadium carbonate. And this is vanadium 4. So again, vanadium plus 4. We look up the formula on our polyatomic ion sheet for carbonate. That's going to be CO3, the minus 2. Again, we need these to add to 0, so we're going to need 2 of those. And so we're going to have VCO3, and then parentheses will be our 2. Then we have 10,2 nitrite. 10,2 means it's plus 2. Nitrite, ITE, we look that up. We find that that is NO2 with a minus 1. Again, the charges have to add to 0, so we need to multiply this by 2, and that'll make it equal 0. So then we're going to have SN, NO2, and then parentheses, and a 2 on the outside. Again, that 2 on the outside is telling us we need 2 ions of nitrite. So then we have titanium 2, titanium, Ti. 2 means it's a plus 2. Acetate, we looked that one up. I like to use the form C2H3O2, but you'll see there's the other form. The other form is just how they're connected. CH3COO is the same thing as C2H3O2. This way is just the way that the atoms actually connect. And so again, we need these to add up to 0, so we're going to multiply here times 2. And so then we're going to get TiC2H3O2 with the 2 on the outside. Last, we have chromium 3. So chromium Cr is plus 3. Hydroxide, we looked that one up. We see it's OH with a negative 1. These have to add to 0, so we're going to have to multiply this by 3. And so we're going to get CrOH. Again, we can't just put a 3 here, because that would just go to the H. We want it to go to the OH. 3. Okay. Alright, at this point, we're finished, and so you're going to next do some classwork problems. You're going to do section B in the classwork problems.